All right, now we have part 3, and that's the should be our last section. But I just wanted to go through the other examples briefly. So the other way you could look at these problems or be given a problem is if you're given the function and then be given the descriptors, and then you have to write the function. So again, I always start with identifying A, H, B, and K. So we start with f of x, and then step 1 says graph is shifted to the left 3. So we know that the horizontal shift or translation comes with the h. Left means it's negative, so h is negative 3. So check. Reflected about the x-axis, we know that reflecting across the x happens through your a. So we know our a is negative. We don't know if it's 1 or some other number, but we know we reflect about x. Next is stretched vertically by a factor of 4. So stretching vertically, if we go back to the definitions, that is our a. So we're factor of 4, so a is negative 4. Yeah, so we got that one. Shifted down 5, this means that a is negative 5. Now we haven't done anything with b, so in this case, b gets left alone. We can't say 0 because it's a multiplier, it's a coefficient out front. So what we have to do instead is leave b as a 1. So f of x now equals negative 4 f of 4 of x plus 3. There was no term, or there was, but it's 1. So that would come out front. And then the whole thing is taken down 5. So x plus 3 minus 5. B, it is A, H, B, K. To the right 2, so H is 2. Horizontal stretch by a factor of 3. Horizontal stretch factor of 3 puts us, well, by a factor of 3, so 1 over absolute b by a factor of 1 over absolute b equals 3. So b, if we were to kind of solve for b ends up actually equaling 1/3. So b comes over here as 1/3. So stretched horizontally by a factor of 3, and then reflected about the y-axis. Reflecting about y means that we must put a negative in our b term. So we have to add our negative to the b. The y-axis done, and shifted up 1, so k is 1. So we're left with, I'll write it down here, f of x equals f of negative 1/3 x minus 2 plus 1. Oh, close that parenthesis. Plus 1. Oh, we didn't talk about the fact that there was no vertical stretch or anything, so we do get to put a as 1. And we can move on to our next examples. Oh, sorry. Our next examples are actually the standard graphs. So these, we do kind of start to expect that you have the general parent function graph memorized. So go ahead and keep practicing those if you aren't comfortable graphing those, because we're going to continue to transform them for this activity. The last thing, well, I guess these ones here, I'll do just one just to kind of give you the idea, but they're asking what happened to the parent function x squared by converting it and translating it under g of x here. So one thing we do is we go through a list of the rules, what happened, we can see the x plus 1 says that we shifted left 1 unit. The negative out front, that would be the negative a. So that's reflect across the x. And then the excuse me, then minus 6 is we shifted down 6. So in terms of our graph, that looks like our domain didn't change. We didn't reflect across the origin. So the domain for x squared is all reals. Here we didn't change anything that would cause the domain to change. So we just say all reals. Now our range starts in x squared. Range is y is greater than or equal to 0. But here we have reflected across the x. So now our graph is down. And it's over in this quadrant here, but it's been flipped across the x, as well as, I mean, it's shifted over, but that doesn't affect our range. It's been shifted down 6. So y is now, instead of greater than, it's less than or equal to negative 6. Kind of a poor representation on the graph, I apologize, but the point still stands. We reflected across the x, we shifted down, so that is how it has affected our domain and range. So these other couple here, it's the same process we've been going through, where it says, here's a given function, here's what happened to it, write the final, I don't know, the final function after it's been transformed. I can do one of these quick. So this time, instead of just saying we start with the function f of x, we're really just looking at absolute value of x. So if we're shifted 3 units left, h is negative 3, reflected across the x-axis, that means our a is negative, we don't know what. It's stretched vertically by 6, so that goes there. And that's it. So we haven't been shifted vertically, so k is 0, stretched horizontally, so b is 1. So f of x, our new f of x, you know what, I'm going to call it g of x. So our original absolute value x becomes, well, negative 6 out front of the absolute value. Instead of x minus h, it's x minus negative 3. And that's it. We don't have any other, we have no b term, we have no a term. So you would continue to do the same thing down the line, b and c. All right, and then just practice problems. So good luck on those. If you have questions, just come see me or email me and we can figure them out. Thanks.